differential equations, our last unit. It's amazing. Okay, starting with lesson 1, solving differential equations by separation of variables. First, let's start. A differential equation is just an equation with a derivative. So nothing crazy there, it just means there's a derivative in the equation. So the first example I'm giving you is pretty straightforward. I have an equation, equal sign, with a derivative, dy dx. If I want to solve the differential equation, I'm trying to find what y is. What was the original equation? So I solve by integrating both sides. So that's what I'm going to do. I'm going to integrate both sides of my equation. When I integrate dy dx, I get y equals, and then I get x to the third over 3 plus c. Now what this is called your general solution. The general solution has a plus c on it. It's not exact, but that's the general idea of the equation. Okay, now what if I have this given piece of information? I'm going to tell you that f of 1 is equal to 2. So that's the piece of given information that I have for you. If you have some given information there, then what you need to do is use that to go back, find c, and find the exact equation. So this is x, this is y. So what I know is that 2 is equal to 1 to the third over 3 plus c. So 2 is equal to 1/3 plus c. Therefore, c is equal to 5/3. And what I'm going to do is I'm going to take that 5/3, I'm going to plug it in, and I've got y is equal to x to the third over 3 plus 5/3. That right there is called your particular solution. Notice my particular solution is an exact answer for y. Okay, so that's our first example. Nothing too crazy going on yet, but don't worry, it'll get harder. Okay, next example that I have here. What I'm going to do is we're gonna solve this differential equation, and I'm gonna write down some steps on the left-hand side, and you're gonna show the work on the right-hand side. Okay, so the first thing you want to do is isolate dy dx. That means solve for dy dx. Get that by itself. So dy dx equals negative x over y. The second thing that you're going to do is multiply by dx. So when I do that, I end up with dy is equal to negative x over y dx. Okay. So now the next thing that I want to do is separate the variables. What that means, I want to get my x and my dx's together, my y's, my dy's together. I want them separated. So when I look over here, if I multiply both sides of the equation by y, I end up with y dy is equal to negative x dx. Notice I have it all grouped together, y's, dy's, x dx. That's perfect, because what you want to do next is integrate both sides. Okay, so what we are going to do is we are going to integrate both sides of the equation. So let's see. When I integrate both sides of the equation, I have the integral of y dy is equal to the integral negative x dx. So that's my next step. And let's see here. We get y squared over 2 is equal to negative x squared over 2 plus c. Now this right here, I'm not done yet, because of course we have to solve for y. I mean, that's what I'm going after all along. So I'm going to go through and multiply everything by 2. Y squared is equal to negative x squared plus 2c. Now remember, c represents a constant. So when I multiply my constant by 2, it's just some other constant. Okay? So now I just square root. So y is equal to the positive and negative square root of negative x squared plus k. Now this isn't a huge deal right here. Constant times 2 is another constant. So a lot of times it'll switch to a k. You can actually leave it as a c all along. It's really okay. Now, that right there is my general solution. Okay, so that's my general solution. However, as you notice, I have a piece of given information for me. So what I need to do is I need to use my piece of given information to go find C. Okay, so I want to take my given information and I'm going to use it back at the first time I have a plus C. So that's what I want to pull. Okay, so previously, let's see, I want to find the first place I saw plus C in my equation, and that would be right up, let's see here. It's going to be up here when I had y squared over 2. And that's what I want to use. It's the first place I saw plus C, so that's where I'm plugging into. So I'm going to have, instead of y squared over 2, I'm going to have 4 squared over 2, which is 16 over 2, is equal to negative, okay, x squared, so that's going to be 2 squared, so 4 over 2 plus C. This is just 8 equals negative 2 plus C. Therefore, C is equal to 10. Hopefully that all makes sense for you, okay? Now, what I need to do is I need to find my equation with my value of C in it. So what I'm going to do now is I know that what I have, y squared over 2 equals negative x squared over 2 plus 10. Again, it's the first equation that had a plus C in it. So that's where I plug, oh, I meant 10, not a C. So I'm plugging in, that's now a 10. Okay? So what I need to do now is solve. Multiply everything by 2. Y squared is equal to negative x squared plus 20. This should make sense. So therefore, y is equal to positive and negative square root of negative x squared plus 20. Now here's the big trick at the end of these problems, okay? I have 2 equations here. I have the positive and negative square root of this equation. I have to find my one final answer. So I need to split this up and say y is equal to the positive square root of negative x squared plus 20. And I'm going to have y is equal to the negative square root of negative x squared plus 20. Okay, so I'm going to have 2 equations here, the positive square root and the negative square root. And what I need to do is figure out my piece of given information from higher in the page. F of 2 is equal to 4. Okay, that didn't even show up, so let me just try to write that out. F of 2 is equal to 4. That was my piece of given information. I'm going to see which equation does that actually work in. If I put it here, I've got, let's see here, 4 is equal to the positive square root of negative 4 plus 20. So let's see here. Let's see if this works. If I have negative 4 plus 20, I get 16. The square root is 16. I want the positive version, which is 4. That's what I want, okay, because that one checks. If I had plugged it in over here, it wouldn't have checked. I would have had 4 is equal to negative square root of 16. I would have had negative 4 equals 4. That doesn't work. So therefore, final answer, let's see here. I'm going to write it up here. So I want the positive version, y is equal to the square root of negative x squared plus 20. That is your final answer. It's the positive version of the radical equation. Okay? Hopefully that all makes sense. Okay. 2 more problems. We're getting there. We're getting there. Now, you guys are really going to like this problem. Example 3. Solve the differential equation. I've got dp over dt minus 5p equals 0, and I've got the given piece of information right there. Given piece of information, 0, 2. So let's see what we can do. First thing I want to do, I want to isolate my dp dt. dp over dt is equal to 5p. Now I'm going to multiply both sides by dt. Okay, now I want to get my p's, my dp's together, and my t's and my dt's together. So I'm going to divide both sides by p, and I end up with dp over p is equal to 5dt. Okay, so now that I've done that, my dp and my p are together, and then I have a dt. I don't even have a t in the equation, so we're all good. What I want to do now, integrate both sides. Now when I integrate dp over p, oh my gosh, it's ln, absolute value of p, is equal to 5t plus c. Oh my god, it's so exciting. Everything always comes back to ln's. Now I have a piece of given information. I know that my given information I have to sub in right away because that's the first time I have plus c, I need to sub in. Here I go. Let's see here. So 0 is t, 2 is p. I'm going to plug in. ln of 2 is equal to 5 times 0 plus c. Therefore, c is equal to ln of 2. Now, at this point, I can drop my absolute value bars because 2 is a positive number. So I know I'm all set there. Okay? So now, let's see what my equation looks like. Let's see. ln, absolute value p, is equal to 5t plus ln of 2. So now I'm trying to solve for y. In this case, that would be p. So if I look at this, ln, absolute value of p, is equal to 5t plus ln of 2. How do I solve for p? Drop the base. Bam! Love it. Drop the base. All of this comes over as my exponent. 5t plus ln of 2 is equal to absolute value of p. Holy crap, awesome, awesome problem. Okay, when I'm adding my exponents, I split this up. E to the 5t times e to the ln of 2 is equal to absolute value p. Amazing. All right, we all know that e's and ln's cancel. Bam. So I've got the absolute value of p is equal to, all of this is a 2 e to the 5t. So that's my absolute value equation, which looks like quite, I've done a lot of work. I think I'm done, but I'm not, never done. So what I need to do is I need to split this equation again. When I have the absolute value equation, that means I have a positive answer and a negative answer. So I have p is equal to positive 2e to the 5t, or I have p is equal to negative 2e to the 5t. So I need to see which one of these equation works. Again, pull down your given information. 0, 2 from the top of the page. I want to plug 0 in for t, 2 goes in for p. 2 equals 2e to the 5 times 0. Well, e to the 0 is 1. 2 times 1 is 2. That checks. Therefore, there's your final answer. Right there. That's the equation of p that we want. P equals 2e to the 5t. Amazing. Awesome, awesome problem. Hopefully you like that one. All right, guys, we're on a roll. I know it's long video. I really hope you can hear my background music because I took a lot of time to pick it out for you. But if you can't, that's okay. It might just distract you. It's Dave Matthews Band, Ants Marching. Anyways, okay, example 4, last one, here we go. At each point, ty, on the curve y equals f of t, the slope of the curve is 20 minus y. If the curve contains the point 0, 15, find its equation. Oh my goodness, I love it. Here's the trick. The slope of the curve is 20 minus y. Well, the slope of a curve is the derivative. So this is telling me that dy dt is equal to 20 minus y. Oh my gosh, I absolutely love this. Okay, so now I had to pull out that equation myself. Now I have to go through the whole process. Let me multiply both sides by dt. 20 minus y dt. And then I want to get my y's over with dy's, so I end up with dy is equal to 20 minus y, and that's equal to dt. See if that makes sense. Hopefully we're good here. Now I have the beauty of having to integrate both sides. So I integrate both sides of the equation. Now, guys, if you thought the last problem was fun, oh my goodness, you're in for a treat here. When I integrate dy over 20 minus y, I have to do a u substitution. U equals 20 minus y. Du is equal to -1 dy, which I don't need that -1. I just have a negative dy. So when I rewrite this, this turns into negative integral du over u, and that's equal to the integral of dt. I don't need to do a u sub on the dt, okay? So now, man, can't even fit all this on the page. Here we go. I integrate, I get negative ln, absolute value of u, which I'll sub in as 20 minus y, is equal to t plus c. Now here's something that I don't think I talked about earlier, so I want to mention it now. When I integrate both sides, I'd have a plus c on both sides. I'd have some constant on the left and some constant on the right. I can always combine them together, so I want my one constant on the right-hand side. I just do it to be consistent, but because it's just a number, I can always combine it onto one side. So that's why you always have it on the right side. So now what I'm going to do is I'm pulling down my given information from the top of the page, and I knew that I had the point 0, 15. That was given to me. 0 goes in for t, 15 goes in for y. Negative ln of 20 minus 15 equals 0 plus c. So therefore c is equal to negative ln of 5. And again, 20 minus 15 is 5, so I don't need absolute value bars anymore because that one's good. Okay, so now that I have that there, I want to go back to where, let's see here, where am I subbing that in? Back up here where I had a plus c. So I'm coming from this equation here. I'm going to do negative ln of 20 minus y equals t minus ln of 5. Okay, so hopefully we're okay with that. Okay, so I have this equation here, and what I'm doing now, I'm going to go through and get rid of that negative. I don't want that there, so I'm going to go through and change all my signs. Ln of 20 minus y is equal to negative t plus ln of 5. Okay, now that I have ln by itself, drop the base. Here we go. E to the negative t plus ln of 5 is equal to absolute value 20 minus y. Bam! Not too shabby. I swear we're getting to the end. Okay, so if I look at this, I again can break this up. Instead of having negative t plus ln of 5, I can split this up and make it, if I'm adding the exponents, I can make it e to the ln of 5 times e to the negative t. And what this does for me is it allows me to cancel out. This cancels, so I end up with 5e to the negative t is equal to absolute value 20 minus y. I have to keep those absolute value bars because that's what's going to tell me how do I split my equation so that I can get my two separate possible equations, see which one checks. So what I'm going to do, I'm going to split 20 minus y is equal to positive 5e to the negative t, and I'm going to have 20 minus y is equal to negative 5e to the negative t. Okay, sub back into my given point, and I'm going to see which equation works for me. So if I look at this, let's see here. It looks like there might be a shadow on the page. I'm trying to get that out of the way. So I'm going to sub back in with my original point, which was 0, 15. I'm going to put 0 in for t. 15 goes in for y. 20 minus 15 equals 5e to the negative 0. E to the 0 is 1. 1 times 5 is 5. 5 equals 5. That checks. Therefore, that equation becomes... And remember, we have to solve for y. So my equation, I'm looking at this right here, 20 minus y equals 5e to the negative t. If I solve for y, then y is equal to let's see, 20 minus 5e to the negative t. What do you think? There's your final answer. I think we did it. Awesome job.